Obviously, Quanta has been in the middle of this whole AI transition, and I have to ask you, what are you seeing in terms of demand for your products?
Talking about product, I think it makes me recall the 2015 Qualcomm developed the first GPU server, AI server, that's a DGX-1.
What if we told you that an AI system can do 5 billion steps without human help or guidance? Sounds unbelievable, doesn't it? Well, believe it or not, that's exactly what NVIDIA, the leading company in graphics and AI, has achieved with their new AI platform, NVIDIA Omniverse Kowloon. This video will teach you about this amazing technology and how it works. First of all, what is NVIDIA's new AI? NVIDIA Omniverse Kowloon 1 is a platform that enables researchers and developers to create realistic 3D simulations of physical environments and agents. Agents can interact with the environment and perform actions like humans, animals, robots, cars, etc. Kowloon is part of the NVIDIA Omniverse 2, a cloud-based platform that connects different 3D applications and allows users to collaborate and create virtual worlds. Reinforcement learning is machine learning that allows agents to learn from their experiences and rewards. It is inspired by how animals and humans learn from trial and error. For example, to teach a dog to sit, one would give it a treat every time it sits down. The dog would learn to associate sitting with getting a reward, and eventually, it would sit on command. Reinforcement learning works similarly, but instead of using treats, it uses numerical rewards. Reinforcement learning algorithms enable agents to learn how to navigate complex environments, perform complex tasks, and make decisions based on the environment state. Kowloon is a platform that enables researchers and developers to create realistic 3D simulations of physical environments and agents. It allows agents to interact with the environment and perform actions similar to humans, animals, robots, cars, etc. One of the platform's main features is that it supports reinforcement learning, which can train agents to perform complex tasks in 3D environments. Kowloon provides a PyTorch API for working with various 3D representations, such as meshes, point clouds, voxel grids, and neural fields. It also includes GPU-optimized operations such as differentiable rendering, conversion between representations, data loading, camera classes, volumetric acceleration data structures, 3D checkpoints, and more. Kowloon uses Proximity Policy Optimization, or PPO, an algorithm that optimizes an agent's policy. A policy is a set of rules that tells the agent what action to take in each situation. PPO tries to find the best policy for maximizing the reward. Using the current policy, PPO collects data from multiple parallel agents interacting with the environment. Then it uses a neural network to update the policy based on the data and the reward. The reward is calculated based on how well the agent achieves the desired goal. PPO repeats this process until the policy converges to an optimal solution. Kowloon provides several examples of PPO reinforcement learning applications, such as bipedal walker, ant, half-cheetah, hopper, and humanoid. But what is the reward for walking? Well, Kowloon defines the reward as the distance traveled by the agent in each episode. An episode is a period during which the agent interacts with the environment. For example, an episode could start when the agent is initialized in a random position and orientation, and end when the agent falls or reaches a certain time limit. The agent's goal is to walk as far as possible in each episode without falling or going out of bounds. This is where Kowloon's simulation capabilities come in handy. Kowloon offers users to create realistic 3D environments with physics-based rendering and simulation. This means the environments look and behave like real-world scenarios. Users can also customize the environments by changing the terrain type like flat ground, hills, or stairs, adding obstacles like walls and boxes, and varying the weather conditions. Using these realistic environments, Kowloon can expose the agent to challenges and scenarios that test its walking skills. For example, the agent might have to walk on slippery ice or uneven rocks, or it might have to avoid hitting walls or falling off cliffs. By facing these challenges repeatedly over millions of episodes, the agent can gradually improve its policy and learn how to walk more efficiently and robustly. But how long does it take for the agent to learn how to walk? According to NVIDIA's research paper, it takes about 5 billion steps for the agent to reach a high level of performance. That's equivalent to walking around 3 million kilometers, or 75 times around the Earth. That's a lot of walking. To put this into perspective, the average human walks about 7,500 steps per day, which means it would take them about 1.8 million days or 4,931 years to walk 5 billion steps. That's longer than the entire recorded history of human civilization. The NVIDIA agent, on the other hand, can achieve this feat in just a few days of simulated training. This is possible because the agent can run multiple parallel environments simultaneously, each with different settings and randomizations. This way, the agent can experience a variety of situations and learn from them faster than a human could. Another interesting fact is that the NVIDIA agent can walk on 2 legs and 4 or even 6 legs. The agent uses a general framework that can handle different body shapes and sizes. The agent can also adapt to different terrains and obstacles, such as stairs, ramps, gaps, and moving platforms. The agent can even learn how to recover from falls and get back on its feet. These are some of the skills that make the NVIDIA agent one of the most advanced and versatile walking agents in the world. Of course, this doesn't mean the agent walks that much in real time. Thanks to NVIDIA's powerful GPUs and parallel computing technology, Kaldin can run multiple simulations simultaneously at high speed. This allows the agent to experience more episodes in less time than it would in reality. For example, NVIDIA claims that Kaldin can run up to 64 simulations in parallel on a single GPU, which means that it can simulate 64 episodes at the same time. This way, the agent can learn faster and more efficiently. The agent can also transfer its learned skills to different bodies, such as a dog, a dinosaur, or a spider. The agent can adapt to the shape and size of the new body and walk accordingly. But why does this matter? Why is NVIDIA's new AI that can walk 5 billion steps important? Well, there are many potential applications and benefits of this technology. For example, it could improve the realism and interactivity of video games and virtual reality. Imagine playing a game where the characters and creatures can move and behave more naturally and dynamically, instead of following predefined animations and scripts. Or imagine exploring a virtual world where you can interact with realistic simulations of animals and humans. 3D deep learning can enable these scenarios by creating realistic 3D models and animations from data, such as images, videos, or point clouds. For example, Disney's animated film Moana used deep learning to create realistic water simulations. It could advance the field of robotics and automation. Imagine having robots that can learn to walk alone without human intervention or supervision. This could enable robots to perform tasks that require mobility and agility, such as rescue operations, delivery services, or entertainment. It could enhance the understanding and modeling of biological systems. Imagine being able to simulate and study how different animals and humans walk and how they adapt to different environments and situations. This could help researchers discover new insights and principles about locomotion and biomechanics, and design better prosthetics and orthotics for people with disabilities. 3D deep learning can enable these scenarios by providing tools for processing and analyzing 3D data, such as meshes, point clouds, voxel grids, and neural fields. For example, Kaldin Library is a suite of tools for accelerating 3D deep learning research, which provides a PyTorch API for working with various 3D representations. These are just some possible applications and benefits of NVIDIA's new AI that can walk 5 billion steps. There are probably many more that we haven't thought of yet. The bottom line is that this technology is a breakthrough in AI research and development, opening up new possibilities for the future. That's all for today's video. We hope you enjoyed it and learned something new. If you did, please give this video a thumbs up and subscribe to our channel for more videos like this. Also, feel free to comment below if you have any questions or suggestions. Thank you for watching, and we'll see you next time.